Hi everyone, welcome back to Newegg TV. Today we have a special video. Once again we have the infamous JJ here from Asus. JJ, thanks again for stopping by.
Thank you for having me.
And what we're going to be doing today is a demonstration of the new X79 platform, the new Sandy Bridge E processors. We have the highest end, which version of the Sandy Bridge E processor?
This is the Extreme Edition, the X part.
This is the Extreme Edition Sandy Bridge E processor. We have a test bed set up here. We're going to be doing some overclocking, and also of note is that we have all 8 DIMM slots populated in here with 8 gig DIMMs in each slot. 8 times 8 is 64. We have 64 gigabytes of memory. And on that note, JJ, you mind if I go over the hardware that we have set up here?
Definitely.
Okay, so 8 gig DIMMs. Corsair Dominator GT memory, that's DDR3, and those are 1866 speed. And yes, JJ is setting this up to run at 1866 speed, that overclock memory. We have a Corsair H100 cooler on top of our Sandy Bridge E Extreme Edition. We have, of course, the Asus ROG Maximus 4 Extreme, Rampage 4 Extreme motherboard. Featuring the X79 chipset. We have 2 Asus Matrix GTX 580 video cards set up in SLI, and then we have the Asus Zonar Sense sound card sandwiched right there in between them. Of course, we also have a Corsair 1200 watt power supply to power all of this hardware, and 2 Corsair wait, which Corsair SSDs are those?
We've got the Corsair Force
yes.
GTs.
The Force 3 GT SSDs, 120 gig SSDs that are behind that fan right there.
Yeah, and then all install this 800D. So pretty insane system. I mean, the big thing that we want to show here is that we've done a lot of work in terms of tuning our UEFI as well as our hardware design to really help to extend the overclocking performance that's capable on X79. Normally, when you're dealing with really high densities, it's very difficult to be able to achieve these high frequency, high density, and high CPU clock frequencies. So be able to get these all to work in concert. There's definitely, of course, a bit of play in terms of CPU margin and making sure you have a CPU that's capable in that regard. But definitely, we've done our job in terms of making sure that the hardware and the UEFI meet those demands in terms of being able to get dialed in and ratcheted up. So I guess we can jump into the UEFI from here.
Certainly. Even without the overclocking, I'm really jealous of this system, but let's see how far JJ can push this.
Well, our goal is, by default, this Extreme Edition part is going to be running at 3.3 gigahertz, and under turbo across the 6 cores and 12 threads, you're going to be looking at 3.6 gigahertz. So we're looking to see if we can really push up the performance. So our goal is to do a 4.8 gigahertz overclock, where we're going to stress it by running ADA stress tests, which supports all the full instruction sets for the CPU at 100% load while simultaneously running Unigen and SLI on both the cards. So I think that'll be a pretty good indicator of system stability and also give us some nice performance metrics in terms of temperature data, what we're looking at under that really crazy type of load.
That sounds good.
So here we are in the actual UEFI. One of the cool things that we want to showcase that's actually going to be present on all our X79 boards is going to be a special shortcut option. A lot of users, while they've given us a lot of positive feedback on our UEFI that's very accessible and it's easy, it's still really ultimately at the end of the day tuned for somebody that's knowledgeable about where different things are. So an example might be if, let's say, I want to adjust the fan controls and I want to increase the actual fan speed, right? If I'm a knowledgeable user, I might know that that's under monitor and then fan control configuration, then go into that option and then I could see that, right? But if I'm a normal user, how am I supposed to know that? Somebody that maybe has never gone into the UEFI, I might not really know all these kind of sub-tree menus. So all the user now has to do is they can just hit the F3 key anywhere within the UEFI, and when I hit that, it will actually bring you a shortcut option interface that will actually take you to multiple parts of the actual UEFI. So case in point, we had fan speed controls where I could just go ahead and click on that and bam, takes me directly to fan speed controls, which is where you can see here, look at the insane amount of fan speed controls that we offer on our boards. Right now I have them set to essentially just silent profile for all the fans that are currently connected to the board, but I could definitely tweak and tune them to my heart's delight at this point. So a lot of nice flexibility in terms of being able to have this nice F3 option where, you know, whether it's, you know, wanting to do a monitor, wanting to flash the actual UEFI, whether I want to actually make adjustments to the CPU configuration, just the VRM settings, all that's available to me here, and I can make those quick and easy adjustments. So really nice option in terms of being able to help have it be a little bit more friendly for somebody that's never had access to the UEFI. But for us, we're really focused here on kind of the nitty and gritty and the diehard enthusiasts. So we've gone ahead and made some key changes in terms of the UEFI. One of the new options that some users are going to see that's not present on 1155 is this CPU strap option. This is important because architecturally now X79 allows for some additional range in terms of BCLK. There's an external clock generator that's now actually on the CPU setup. And what that allows is a decoupling from the other buses. So like let's say your PCIe or SATA or USB 3, and that allows this to go ahead and be raised in higher increments. Now this still doesn't change the increments between each strap. So if let's say I was to set 125 megahertz, once I set it to that, doesn't mean that I could start going, you know, 126, 127, 128, 130. I still have relatively the same finite increments that I had on normal 1155 Sandy Bridge, so maybe +3 per strap. The main benefit is that with the setting of the strap, it also will reset the actual memory divider, so that, take for instance, maybe if I had a kit of 2000 based memory, where under the 100 strap, I don't have a 2000 memory divider, I only have 1866 or 2133, I would now have a 2000 memory divider. So this once again reaffirms why X79 and Sandy Bridge E is really the most enthusiast-based platform in terms of customization and configuration for overclocking. For our specific situation, we've gone ahead and decided to go straight for the multiplier focus to put a little bit less stress on the IMC, so the integrated memory controller, although we have seen situations where the strap can help to correlate to better stability for some memory dividers, depending on your density and your frequency.
It's just another option that you have that was maybe cut off before with the original Sandy Bridge implementation.
Correct. So we've gone ahead and defined that 48 multiplier, our 1866 memory frequency. I've gone ahead and gone into our extensive DRAM timing controls and really dialed in a lot of specific values to be able to make sure that we have the flexibility to be able to have this 64 gigabytes worth of memory run stable.
I think extensive controls is kind of an understatement.
And I've gone ahead and made some modifications in terms of our voltages, namely VCCSA and VCT, which are kind of key for high density, high memory configurations. So with that said, we've got everything dialed in. Let's go ahead and see if she posts and goes ahead and boots.
All right.
So we're going to go ahead and save these configuration settings and go ahead and boot up. You know, one thing that we do want to note is definitely with overclocking, there is going to be variance within the CPUs themselves, but in most situations we expect most of the Extreme Edition parts to generally hit a frequency of about 4.5 to 4.6, with then a good amount also being able to hit 4.7. After about 4.7, you're going to start to see more margin come into play, depending on the CPU and the cooling in question in terms of being able to achieve 4.8, 4.9, or even 5 gigahertz. Depending on the cooling configurations, though, we do think that even under very well-cooled configurations, 5 gigahertz could potentially be done, but it's also dependent on the level of load that's implied. You know, there are some users that use unrealistic stress tests, take for instance like maybe like Prime 95 or something like that. While it can be an indicator of system stability, it doesn't stress all parts of the bus, and it doesn't use all the architecture of the CPU like AVX or AES instruction sets or other important parameters that should be tested when you're trying to quantify stability for the CPU.
But for most folks using a decent air cooler, you think 4.4, 4.5 should probably be pretty easily attainable.
Definitely. And a lot of our kind of like basic auto overclocking parameter profiles, we've set those to generally be about 4.2 to 4.3 gigahertz, and that's generally achievable on something like a kind of Hyper 212 Plus. Cooler Master has an excellent model coming out that will be the actual 412, which will replace that, will work quite well, or like a Corsair H60. Those are pretty economical coolers that you can go ahead and utilize and be able to get somewhere between that 4.3 to 4.5 marker. And keep in mind that not only do you have that significant increase in cache, but you've also got, of course, those 2 additional physical cores, and then you have the hyper-threading, so you have 12 cores. So quite a bit more horsepower at that relative frequency than you would have on the normal Sandy Bridge part.
Oh yeah.
So we've gone ahead and posted and booted successfully, no issues here. So we're going to go ahead and now get the party started, right? So we're going to go ahead and open up Ada64, which is my preferred system utility.
Now, if I heard you right before, you said you're going to be running a CPU burn-in test, the Ada64 CPU stress test, and Unigine heaven at the same time.
That's right. And the main reason why is I like this combination because Ada works very closely with us as well as the actual CPU partners to actually create an actual testing algorithm that tests multiple parts of the CPU instruction set. So as I noted, things like AVX, AES, SSC, other instruction sets to really make sure that it's using a lot of that. It's not just about integer and heat. We want to actually test the instruction sets. And I run the SLI configuration because a lot of these more demanding stress test applications don't take advantage of stressing the system bus whatsoever. And that's critical because what are you going to do when you're done overclocking? You're going to kick in Battlefield 3 and you're going to start going online to play, right? So you want to make sure that you're actually testing the subsystems as well. So that's part of the reason why that we're going to go ahead and run the 3D load. So that way we get communication between the actual graphics cards, the rest of the bus, the CPU, and we kind of an overall process flow.
It's from a general perspective, assuming you can run both of these at full load, you're probably okay in just about any other
in most situations,
situation.
I would say, yes. It's going to be very rare. I mean, there's always the possibility with overclocking. You're going to always run into possibility that you could still get a variable to come into play. But in most situations, if you can pass these two things running simultaneously on the platform, you've got a stable system.
All right.
So we're going to go ahead and ratchet it up here. We'll go ahead and not run it full screen so that way we can see the Ada at the same time as Unigine. And we'll go ahead and open up our system sensor monitor here within Ada so we can take a look at power draw and temperatures and some other variables like that. So first, we'll go ahead and kick this on to 100%. We can see the fans have gone ahead and ramped up now at this new increased frequency. We can see, bam, we have all 12 cores now being 100% loaded. And now we're going to go ahead and also initialize the Unigine run. So this will go ahead and attempt to load here in the background. We've got the memory going. We'll get our task manager, we'll get Ada back in play here, and we can see all our information. So we've gone ahead now and increased our CPU package. We're definitely increasing the actual wattage consumption. We're almost at 170 watts alone just for the CPU at this overclocked frequency. But you can see our H100 is doing quite a good job in terms of keeping our CPU cool even with this 100% load. Is that ideally in most situations we're going to want to try to keep a nominal temperature across all cores about maybe 75, ideally under 80, closer to 75 would be great, especially for this architecture. It tends to be able to help to extend OC performance closer to about the 75C marker. So we can see though that the system is definitely still running.
Most of our cores right now hitting maybe 75 is the highest I'm seeing. I do see one up to 80. Yep. 78, but fluctuating right around that mid to upper 70s range.
Yeah, we have sometimes floating down to 60, 74. You're going to get, of course, variance per the cores, different instructions being loaded in and out and things along those lines. But we're in that target range of what we're looking to do. And like I said, this is achievable with a realistic air-cooled configuration. One note is that with the H100, we've done a little bit of a different configuration that I do recommend for our X79 platforms, is instead of the normal exhaust out, we've actually have the fans drawing air and then blowing downwards. And that benefits us because we're actively cooling this high density memory configuration where we have airflow going over each set of DIMMs. And then we also have air flowing over actually the VRM and the backplane of the VRM. And that's critical in helping to stabilize these higher level overclocks. So definitely users that are setting up their systems are going to want to be aware of this.
So very helpful to have those fans pointing downward just to get that enhanced airflow over the board.
Correct.
And also you're recommending that the closed loop coolers like the H100 here, very nice for the X79, the 2011 platform, just because you have such limited space there around the DIMMs that if you're cooling your CPU and you have, say, one of the air coolers that blows air down towards the motherboard, you're actually going to warm up your DIMMs and make it more difficult to have a stable
Correct.
overclock.
You could significantly complicate, especially in these high density, high frequency situations. I mean, here we're pretty much running the highest end kit configuration on the market that's possible. And really, this kind of closed loop configuration is going to work best because, like you said, if we were to use a fan configuration, definitely could still probably achieve close to that 4.7, almost 4.8 gigahertz, but you're going to be exhausting so much of that heat onto this VRM, excuse me, this portion of the VRM as well as these DIMMs, you could be really causing a lot of instability. And as we've noted before, this area is the most complex part of the board because not only does it have all the traces for the memory, but there's also all the other traces for the actual I/O. And now in the background, as we can see here, what do we have running? We've got Unigine actively running here in the background at the same time as running the actual 100% stress test. We still see 100% CPU utilization pegged. Our even wattage even peaked up a little bit more. We saw it peaked out almost 180 watts for the CPU package. Overall, right now, this system is probably getting close to almost 900 watts of continuous draw. But definitely you can see that ROG is proving itself in this situation where we're running 64 gigs worth of memory on the system, where we can go ahead and take a look at actually the 64 gigs, where we can see right here we have the active memory in terms of the system. You can see all our DIMMs in terms of each one of those DIMMs being populated.
Now, some people might say this is a little bit of overkill with the 64 gigs, especially considering that our actual physical memory usage is at 4.73 gigs right now.
Correct.
What are some other applications that people out there can do with the capability to have so much memory now?
You know, that's a great point. So we've discussed in terms of one of our focus points in terms of why we decided to go with a 64 gigabyte, with an 8 DIMM configuration to enable things like 32 gigabytes or 64 gigabytes, was to be able to offer more flexibility. And one of those specific reasons was so that we could do things such as like a RAM disk or a RAM cache. So with a RAM disk or a RAM cache, what we can actually do is we can create one, let's say maybe an 8 gigabyte or 16 gigabyte volume worth of memory to cache directly all your executables through system memory, or we could actually have a RAM disk. Now, a RAM disk would actually be an installable volume, shows up just like a D drive. With that D drive, we could actually install something like Battlefield 3 onto that and run that directly. Now, what would be, let's say, the performance gains of running a configuration like that? Well,
I think you might have some benchmarks.
We do have some benchmarks here, so let me see if I can go ahead and pull these up. Okay, so here we've actually got some results for showing you actually the differential between normal, awesome Corsair Force GT SATA 60 SSD.
Normal SSD.
Right,
kind of
fastest,
top of the end right now,
yeah,
but still
SSD you can get, right?
A very good SSD.
So here we just have, not the specific Corsair, but we have a SATA 6G SSD here on that we can see right here. We can see super impressive performance, right, in terms of what's achievable here, right? We keep in mind that this is the most taxing type of testing done, right, in terms of the actual type of data being passed through. And now we're going to go ahead and take a look at, with this type of data configuration where, let's say we're running, like I said, 8 gigabytes for the OS, 8 gigabytes for the RAM disk, and then maybe 8 gigabytes for the RAM cache and 16 gigabytes for RAM disk. This would be the type of permutation. For here with 64 gigs, we could even make it bigger, right, because we could even have a bigger RAM disk. But we'll first start off with just a 1333 RAM disk. And let's take a look at the performance increase. And we can see it's...
I think it forgot the decimal point right there. Shouldn't there be a...
Yeah, where you can just see that the performance increase is just...
That's 4,900 megabytes per second read. Basically 4.8 gigabytes per second read. 7 gigabytes per second write.
Yeah, and you can see that the 4K performance is just a massive explosive increase in performance. So the attractiveness of being able to run this type of configuration is just crazy. And the cool thing is that now with the type of software configurations that are available, you can have even a persistent RAM disk volume. So even when you shut down the system, you can still have this actual volume be addressable when you reboot it. And there's other interesting permutations that you can do with even RAM cache as well. So this RAM disk is really cool, but this is also adjustable, right? When we talk about an SSD, right, once you get to that fastest type of SSD on the market, right, you're limited by the actual bus. You can't get faster than 600 megabytes unless you decide to RAID, and even in RAID, you won't ever see numbers as close as it's to this. But with memory, guess what? You can get faster memory, can't you? This was only run at 1333, so we're essentially running at stock memory values. So if we go ahead and now up the envelope and we run at 2133, maybe like a 32 gigabyte configuration, we can see that we can continue to actually increase the actual throughput performance offered. We've now gone up to, look, 5 gigabytes on the read, 5.6 gigabytes on the write. In Crystal Mark, we've gone almost 7.7 gigabytes in terms of the actual write performance, 5.8 gigabytes in terms of the read performance sequential. But the really impressive stuff when you look at it is the 4K performance. When you compare that to 4K performance on an SSD, it makes the SSD just look like
slow.
Yeah, it just makes it look slow. Even when you compare the SSD numbers to mechanical volumes where you thought that 30x delta was impressive, now you're easily exceeding that value. So this makes for some very interesting configurations.
I like the access times here, 0.004 milliseconds and 0.006 milliseconds. Yeah. That is some fast response time.
And you can see also here a really interesting performance metric is in the actual ISO programming game copy data. So in the real user situations for installations or copies of type of applications, we can see that we have a just massive increase in the type of performance, really minimal impact times, so you actually get a real usable benefit.
So some impressive numbers for sure with the RAM disk, but you're also mentioning earlier that you can use all of that memory as a RAM cache. Can you give us more info on that?
Yeah, you can definitely do a lot of interesting permutations. Like I said, with a 32 gigabyte, 64 gigabytes, you can do a lot of interesting things in terms of running, like I said, local OS on some of the memory, then a RAM cache, and then also still have that RAM disk for actually locally installing applications. The benefit of the RAM cache is you can really help to extend the performance of start application performance and overall system actually functionality in terms of, like, let's say files being copied, antivirus scans, importing of photographs, editing, all kinds of different variables because you're actively using that memory as an executable and application cache. So we can take a look here at PC Mark 7, which is a very good indicator of overall system performance and overall metricing storage performance. Now we can see here, this is our normal SATA 6G SSD, very fast, impressive score relative to the X79 platform. But what we specifically want to look at, and one of the areas that's most impacted, now keep in mind it's not the only benchmark here within the actual PC Mark 7 score. A lot of variables actually are affected by the RAM cache. But when we take a look here at the storage system score, we can take a look here at the starting application performance on the SSD, peaks out at approximately 21.06 megabytes. And then when we move over here to the PC Mark 7 score, which is the SATA 6G SSD with the RAM cache, we can see here it's 122 megabytes, almost 123 megabytes, so 122.93.
It's about 5 times faster?
Yeah, so a huge increase in the overall start application performance. So there's some really cool flexible configurations, and this is part of the reason that we reinforced wanting to go with 8 DIMM configurations on all our launch boards, is to be able to have these users be able to take advantage of 32 gigabytes, 64 gigabyte configurations, and also the correspondingly higher speeds, because as we saw, same thing like in the RAM disk, you actually are getting a benefit not only from having these higher densities, but also having these higher frequencies because we have more bandwidth available to us.
Now, since we're on the topic of faster data transfer speeds, there's one other thing I know you wanted to share, and that is the USB 3.0 feature that is in all of the Asus X79 boards. You
got it. So this feature that we discussed in terms of being a special option on all our X79 boards is our Asus USB 3 boost technology. And what this essentially is, as we discussed before, is there's 3 modes of USB operation. We have BOT, SCSI, and then the new standard, which is UASP. And these essentially all change the way that the actual information is transmitted across the bus, with BOT being the oldest legacy standard going all the way back to the original USB specification. Not supporting any type of queuing, it doesn't support multiple commands, it has a lot of limitations. It still works, and you can get increases as you increase the throughput on each bus, but it's very limited in terms of showing the maximum level performance. The SCSI implementation, which is a turbo option, and we call it within our AI Suite 2 USB 3 Boost interface, is great for taking non-UASP USB 3 devices or even USB 2 devices and extending their performance. But what we want to show here is USB 3.
Okay.
So here we actually have a UASP enabled device. So we have a specialized controller here that has UASP supported firmware, and then we have an SSD internally in here. And we can take a look here that when we launch our AI Suite 2 application, we have a very easy option here that's called USB 3 Boost. And right now we've already gone ahead and enabled UASP mode of operation to show the new increase in performance. So here on the left, we can see that we have some very respectable USB 3 speeds, right? We're peaking out at approximately 250 megabytes here on the right, and then about 226 megabytes here on the read. So quite good, right? But when we've enabled now this UASP support, still the same SSD, there's no change here. The only difference is being a UASP enabled firmware along with our hardware controller, our firmware and our driver that we have exclusive on our boards, is we now have then an increase in performance on write 366 megabytes, and then for the read 336 megabytes. So huge increase in terms of the performance achievable. So you can imagine for anything, whether you're copying, system backups, general file transfers, all those things are going to see a huge uptick in performance.
So over 100 megabytes per second faster just by enabling that UASP mode with the proper hardware and firmware, of course. That's just the boost you get from the USB 3.0 transfer speeds.
Yeah, so it's a very cool, realistic, real-world implementation. So we do spend a lot of time to make sure that we have some really cool high-level features, you know, like our advanced digital power design, where we have, you know, the digital controller for the DRAM, digital controller for the VRM, but we still also want to make sure to offer these things, which anybody can use each and every single day. And like I said, even for like a normal USB 3 device, so here we've got like this Corsair Flash Voyager TT USB 3. This doesn't support UASP, but if we were to go ahead and plug it in, what will happen is the device will be recognized, and we can see it here, and you can see that it no longer gives us the UASP option, right, but it gives us a turbo option. So we could still go ahead and have that device, and we see that actually our software automatically remembers that I've previously plugged this in and automatically shifted it into turbo mode for operation. And we could still also get an increase in performance. Now, of course, depending on the device, for both USB 2 or USB 3, the increase isn't always going to be as extensive, of course, as it was for UASP, because it doesn't support the same advanced protocol transmissions that UASP supports, but you'll still see an increase. The other overall big benefit is that for both turbo and for UASP compared to bot, they will use less CPU utilization, and they have improved latency performance, so meaning that they actually have less latency. So all around, they're big pluses in terms of being able to have this across all our X79 boards.
So if you've got that, pretty much no reason not to use it.
Yeah, definitely. There's no reason not to use it, but the only way that you do have access to it is through our AI Suite 2 interface, because it does require a special adjustment to the low-level driver itself through the USB 3 controller. So to be able to make sure to take advantage of that, you do want to make sure to have AI Suite 2 installed.
All right. And on that note, I think we are going to wrap it up. Was there anything else you wanted to share today, JJ?
I think that covers it.
That covers it. All right, guys, this has been our video. Just some little use case scenarios, some overclocking, a quick system demo here showing the maximum amount of memory that you can install in the current X79 boards. JJ, thank you very much again for stopping by and sharing all of this information with us.
As always, thank you for having me, and like I said, we'll definitely continue to have more content available for all our Asus users. If they want to check that out, just head over to the Asus ROG forums.
All right, guys, Asus ROG forums for more information on the Asus products, Asus ROG YouTube channel as well if you want to see more videos with JJ. At least the ones that he's not doing here with us at Newegg TV. Of course, Newegg TV YouTube channel, youtube.com/Newegg. For more tech videos just like this one, please feel free to subscribe if you enjoy these videos. And that's going to wrap it up. I'm Paul with Newegg TV. Thank you very much, everyone, for watching. We'll see you next time.